Top 10 Weirdest Quantum Technology in Use Today. In this video, we're going to look at the top 10 of the weirdest quantum technologies that are in use and being further developed today. For more videos like this, don't forget to subscribe to my channel at youtube.com/JoshPeckDisclosure and at the subscribe link in the annotations and below the video. For more information on any of these topics, check out the links in the description below. Number 10, quantum computing. Quantum computing isn't a fully realized technology as of yet, at least as far as we know, but many things within the umbrella of quantum computing are being employed today. Quantum computing uses the strange behavior of certain subatomic particles to achieve the impossible. This behavior is known as quantum entanglement. As of now, quantum entanglement is a complete mystery. When two particles are entangled, they have the ability to communicate with one another at instantaneous speeds, speeds that are even faster than the speed of light. This is thought to be physically impossible because of all the paradoxes that faster than light speed is supposed to cause. For example, the closer one accelerates to the speed of light, the slower time moves for the traveler. At the point the traveler reaches the speed of light, time literally stops. If somehow the traveler could accelerate even faster, time would begin running backwards. There is also the problem of mass. The closer an object comes to the speed of light, the more mass it gains. To reach the speed of light, an object would have infinite mass, which would, of course, be physically impossible. Photons, the particles of light, are massless by nature, which is how they can travel at such an incredible speed. The idea is to use quantum entanglement to create a computer that can run and process information at infinitely faster speeds and power than is available today. The beginning stages of quantum computing is available today and, when fully realized, will radically transform the world in unimaginable ways. Number 9, quantum camera. A recent experiment showed for the first time ever that something called a quantum camera can be functional. A conventional camera captures light that bounces back from an object, but in the experiment reported in the journal Nature, light particles, or photons, that never strike an object are the ones that produce its picture. In the new experiment, the physicists entangled photons in two separate laser beams with different wavelengths, and hence color, one yellow and one red. The team passed the red light beam through etched stencils and into cutouts of tiny cats and a trident about 0.12 inches or 3 millimeters tall. The yellow beam traveled on a separate line, never hitting the objects. What's more, the etched shapes were designed to be invisible to yellow light. After the red light passed by the objects, the physicist ran it together with the yellow laser beam at both parallel and right angles. The red light was then discarded and the yellow light headed for the camera. There, that yellow light revealed a picture of the object, and a negative of the picture emerged from the light that had interfered at a right angle. This is the first time the strange phenomenon of quantum entanglement has been used as an imaging technique in this way. Number 8, infinite microchip. For the first time, scientists have achieved infinite speeds on a microchip. Although this advance will not enable faster-than-light starships, the light warping technology behind this innovation could lead to new light-based microchips and even enable powerful quantum computers, researchers said. Light travels at the speed of about 670 million miles per hour in a vacuum and is theoretically the fastest possible speed at which matter or energy can travel. Exceeding this speed limit should lead to impossible results, such as time travel, according to Einstein's theory of relativity. However, in a way, researchers have overcome this barrier for decades. To understand this feat, imagine a pulse of light as a packet of waves all blended together. The energy of this packet rises and falls across space, cresting somewhere in the middle. If a pulse of light encounters a material that absorbs, bends, or scatters light, the wave making up this packet can interfere with each other, driving its crest forward. This can make the speed at the packet's crest, known as the phase velocity of the pulse, faster than light. When what are known as zero-index materials enter the mix, light no longer behaves as a set of moving waves zipping through space, as a series of crests and falls. Instead, in zero-index materials, light behaves as either all crests or all falls, stretched out to infinite wavelengths and traveling at infinite speeds. Now, scientists have, for the first time, woven a zero-index material onto a microchip. Zero-index materials that can fit on a chip might also help advance quantum computers, which can theoretically carry out more calculations in an instant than there are atoms in the universe. By stretching wavelengths of light to infinite lengths, zero-index materials could enable even distant particles to become entangled. Number 7. Quantum code. For the first time, Australian engineers have demonstrated that they can write and manipulate the quantum version of computer code on a silicon microchip. This was done by entangling 2 quantum bits with the highest accuracy ever recorded, and it means that we can now start to program for the super powerful quantum computers of the future. Engineers code regular computers using traditional bits, which can be in one of 2 states, 1 or 0. Together, 2 bits create code words that can be used to program complex instructions. But in quantum computing language, there's also the possibility for bits to be in superposition, which means they can be 1 and 0 at the same time. This opens up a vastly more powerful programming language, but until now researchers have been unable to figure out how to write it. Now, engineers from the University of New South Wales, UNSW, in Australia have demonstrated that not only can they do this, but they can do it on silicon microchips very similar to the ones that make up today's computers, which means this technology will be easy and quick to scale up. This technology also relies on quantum entanglement to operate. Number 6. Parallel universe detection. In a recent article, it was stated the LHC at CERN is just days away from breaching higher dimensions. This article states, scientists conducting a mind-bending experiment at the Large Hadron Collider next week hope to connect with a parallel universe outside of our own. The proposed method is to use the LHC to create miniature black holes to breach these higher or parallel dimensions. There is a theory called rainbow gravity theory, sometimes referred to as gravity's rainbow, that, if true, would allow miniature black holes to be created at relatively low energies. The controversy surrounding rainbow gravity theory is it also predicts the universe to be infinitely old. Normally in physics, when the solution to a problem is infinity, the solution is thrown out because it is rendered meaningless and nonsensical. In fact, German mathematician Carl Friedrich Gauss denied that anything infinite really exists, saying infinity is merely a way of speaking, and I protest against the use of infinite magnitude as something completed, which is never permissible in mathematics. Despite the controversy, however, scientists at CERN are using the LHC to attempt detection of parallel universes and higher dimensions. Number 5. Unlimited energy teleportation. A team of physicists has proposed a way of teleporting energy over long distances. This technique, which is purely theoretical at this point, takes advantage of the strange quantum phenomenon of entanglement where 2 particles share the same existence. The system developed by physicists exploits properties of squeezed light or vacuum states that should allow for the teleportation of information about an energy state. In turn, this teleported quantum energy could be made usable. Unlike teleportation schemes as portrayed in Star Trek or The Fly, this type of teleportation describes entanglement experiments in which two entangled particles are joined despite no apparent connection between them. When a change happens to one particle, the same change happens to the other, hence the impression of teleportation. Physicists have conducted experiments using light, matter, and now energy. According to physicists, a measurement on the first particle injects quantum energy into the system. Then, by carefully choosing the measurement to do on the second particle, it is possible to extract the original energy. Number 4, quantum alchemy. One of the main goals of alchemy in the ancient past was to transmute one substance to another, more specifically base metals to noble metals such as gold or silver. Ancient alchemists also had the goal to create the Philosopher's Stone, which was fabled as being a substance that could transmute metals as well as provide immortality to the one wielding it. The LHC smashes protons together to form new and exotic particles. The way this works has not been adequately communicated to the general public. Basically, it all starts with quantum fields, the study of which is known as quantum field theory, or QFT. Everything in existence is fundamentally produced by quantum fields. Particles are really nothing more than waves in quantum fields. Matter and energy are essentially the same thing. When a field has enough energy in a localized area, that spike in energy is what we recognize as a particle. It's not that the energy spike or wave creates a particle, rather, the energy spike is the particle. This is true for all elementary particles, such as quarks and photons. When two protons collide in the LHC to create a brand new particle, it is not that these protons are combining their substances to rearrange into a new one. What's happening is the protons are being obliterated and the released energy goes into other quantum fields, thereby creating a wave in a different field, which in turn is recognized as a new particle. In other words, physicists are literally changing one substance into another. The LHC can be thought of as the world's largest transmutation machine. Number 3, Wakefield Accelerator. There is a new experiment at CERN on the horizon. This new machine will have the stunning ability to accelerate particles 1,000 times the current acceleration of the LHC. Particle acceleration will be done in a completely new, innovative, and cost-effective way. The new accelerator, aptly named AWAKE, or Advanced Wakefield Experiment, will use a technique that effectively surfs particles on waves of electric charge created in a plasma or ionized gas. This technique will allow future accelerators to run at a much higher energy without increasing the size or cost of the machine. Most colliders today, such as the LHC at CERN, use giant magnets and electric fields to accelerate particles through a tunnel. The problem is there is a limit to the energy that can be sustained in these types of colliders. If the electric field is too strong, it can cause a spark, which, for obvious reasons, would be a very bad thing. Plasma Wakefield accelerators, however, are different. They send a pulse of charged particles through a plasma, which causes electrons and positively charged ions to oscillate. These oscillations cause regions of alternating positive and negative charge, which in turn forms waves that accelerate charged particles. When these charged particles are introduced at the right time, they ride along these waves. Since the electric fields of plasma Wakefield accelerators are stronger than regular colliders, they can accelerate particles as much as 1,000 times greater. On September 18th of 2015, the council that governs CERN approved funding for the AWAKE project. There are a few prototype plasma Wakefield accelerators in existence today, but this will be the first time CERN will experiment with the idea. AWAKE will also be the first to use pulses of protons instead of electrons in such an experiment. With more acceleration, CERN will be even closer to realizing its goals of breaching higher dimensions and parallel universes. AWAKE will be able to fit in the palm of your hand. This means it is a much cheaper and far more mobile accelerator that, eventually, other organizations and even individuals could have access to for their own private experiments. Number 2, quantum AI. Physicists admit that while they know much about the quantum world within our day-to-day lives, consciousness has eluded them. Quantum brain dynamics, or QBD, is a theory that states there is a new quantum field that is responsible for consciousness. This hypothetical field is known as the cortical field. The quanta, or elementary particles, of this field are known as corticons. If this turns out to be true, it would mean our personal consciousness exists by means of interaction with a quantum field, or due to interaction by quantum particles. Due to the rules of quantum field theory, if the right amount of energy is applied to the cortical field, it could produce corticons. Conceivably, this could be done at particle accelerators such as the LHC at CERN. There are scientists today who are already trying to tackle the mystery of consciousness. Given that this could be tested with our current technology, it causes one to wonder what the future might look like if any of these quantum consciousness theories turn out to be true. There are enormous technological implications to a discovery such as corticons. The solution to how to make artificial intelligence a reality would be realized. This also would provide a relatively inexpensive way to do it with limitless resources. All one would need to know is how to manipulate the cortical field and/or corticons themselves to keep them active inside a computer or other technological device. How much easier would it be to create real consciousness out of thin air by manipulating nature rather than spending an unimaginable amount of money to research and develop computer code and software that can handle an artificial intelligence? If corticons are found, it would be far easier and more cost-effective to apply corticons into a machine or to build a machine that can manipulate the cortical field, thereby causing that machine to be conscious, aware, and even alive. Number 1, graviton communication development. The graviton is the particle responsible for the gravitational force. It is the quantum of the gravitational field. What makes the graviton especially interesting is its apparent ability to flow free between dimensions. What this means is, if the theory is correct, gravity can travel to higher dimensions and higher dimensions can affect gravity. There is an idea that gravitons can be used as a way to communicate with beings of higher dimensions. This may sound like the stuff of popular science fiction, but physicists today are seriously considering and working on this possibility. Popular physicist Brian Greene even discussed this in a physics documentary he narrated. The idea is to string gravitons together in a type of binary code, send them into higher dimensions, set up a detector, and wait for a reply. If gravitons are used as a way to communicate with beings of higher dimensions or parallel universes, this might be what tells us that we're not alone. While many are waiting for a type of disclosure event in which otherworldly beings present themselves and their spacecraft to humanity, we might be surprised to find these beings presenting themselves in a different way. This may begin with an established communication via gravitons. This has been the top 10 weirdest quantum technology in use today. For more information on any of these topics, check out the description below. If you haven't done so already, don't forget to subscribe to my channel for more videos like this one. Also, feel free to comment, rate, and share. Thank you for watching, and as always, take care and God bless.